Welcome student in Christchurch Convent Digital Classes, Class 11, Chapter 2. Today we'll see one important concept. We'll learn about quantum numbers. So generally question is asked, what are quantum numbers? How many types of quantum number are there? Explain the information obtained from them. So what are quantum numbers? How many types of quantum number are there? Explain the information obtained from them. So its answer is the calculation of laws of quantum mechanics gives certain numbers which can be used to trace out the possible states of electron, such as location, energy of electron are known as quantum numbers. There are four types of quantum numbers. So quantum numbers gives the information about location, orbital occupied, orientation, shape, and energy of the electrons, which are distributed according to certain rules in different orbitals. So there are mainly four types of quantum numbers. Characteristics of these are given in the next slide. First, first type of quantum number is principal quantum number, which is denoted by small n. Now, what is the function of principal quantum number? This shows the principal orbit of electron, means the electron whether occupied K cell, L cell, M cell or N cell. For K cell, n is equal to 1, as you can see in the table. For K cell, n will be 1. For L cell, n will be 2. For M cell, n will be 3. For cell n, n will be 4. For cell O, M, n will be 5. And for cell P, n will be 6, and so on. So the principal quantum number values starts from 1, 2, 3 and so on. From this quantum number, that is from small n or principal quantum number, we know about the average distance of electron from the nucleus and energy state. The energy states corresponding to the different principal quantum numbers are designated by letter K, shell. These are also called cells, energy cells. So K is the energy cell, L is the energy cell, M is the energy cell, and N is the energy cell, etc. and so on. So for K cell, N is equal to 1. For L cell, N is equal to 2, and so on. After this, the next important quantum number is azimuthal quantum number, which is denoted by a small l. From this, we know about the angular momentum and the shape of orbital. For each value of principal quantum number, L has the value from 0 to n minus 1. Mind this, remember this, which shows the suborbital obtained different values of L corresponding to n are, if when n is equal to 1, then L is equal to 0. If n is equal to, when n is equal to 2, then L is equal to 0 and 1. And if n is equal to 3, then L is equal to 0, 1 and 2. And if n is equal to 4, then L is equal to 0, 1, 2, 3. These orbitals are designated by letter S, P, D, F for the corresponding value of 4. Thus if we take L is equal to 0, then the subcell will be S orbital, and if the value of L is 1, then we'll say P subcell, and if value of L is 2, then we'll say D subcell, and if the value of L is 3, then the subcell will be F. The third important quantum number is magnetic quantum number, which is denoted by small m. This explains the effect of spectrum of atom when kept in magnetic field known as Zeeman effect. For each value of azimuthal quantum number L, m has value from minus L to 0 to plus L. That is total 2L plus 1 values. Means, suppose if L is equal to 0, then m is equal to 0, and if L is equal to 1, then m has 3 value, minus 1, 0 and plus 1. And if L is equal to 2, then m is equal to minus 2. The value of m will be 5 values, 0, minus 1, 0, plus 1, plus 2. Now if L is equal to 3, then m is equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. If L is equal to 0 means for S subcell. If L is equal to 1, then means P subcell. L is equal to 2 means D subcell. L is equal to 3 means 7 subcell. F orbital, there are 7 orientation. So it tells about the orientation of the orbitals in space. That is, if L is equal to 0, m is equal to 0, then S orbital has one orientation, that is spherical. P orbital has 3 orientation, D orbital has 5 orientation, and F orbital has 7 orientation. Now spin quantum numbers. The electrons moving around the nucleus spin on its own axis in left, then we'll denote it with downward arrow, and in the right side then they will have upward arrow, denoted by upward arrow. For each value of m, S has two values. Spin quantum number has two values, either plus half or minus half. Now what is the use of quantum number? It helps in writing the electronic configuration in a systematic way or in systematic manner. Secondly, each electron of an element can be recognized separately because of any two electrons cannot have the same value of all the four quantum numbers. The second one is also known as Pauli's exclusion law. Thank you for watching the video. See you in the next video. This is most important topic. Please go through and learn it properly.